Hey guys, it's Mrs. Kerr. So I'm going to be going through a free response to help us review binomial geometric distributions. This is from the 2011 exam. This is Form B number 3. And the problem says an airline claims there is a 0.1 probability that a coach class ticket holder who flies frequently will be upgraded to first class on any flight. This outcome is independent from flight to flight. Sam is a frequent flyer who always purchases coach class tickets. And part A asks us, what's the probability that Sam's first upgrade will occur after the third flight? So before we even get into solving this exact part, I just wanted to do a quick refresher of how you can tell if something is binomial or geometric. So you may remember this acronym called BINS. Okay, so the B stood for binary. There's two outcomes, success and failure. The I stood for independent, that each trial is independent. The N, I put a star by the end because depending on what's true about the N, that helps you decide if it's binomial or geometric. So if the number of trials is fixed and you're counting the number of successes in those trials, that's a binomial. Binomial is fixed number of trials. If the number of trials is not fixed and you're counting the number of trials till you get a success, that's geometric. So this is the one that helps you decide if it's binomial or geometric. These other three will always be true no matter what, if it's binomial or geometric. And then S stands for success probability is the same for each trial. So if when you take the AP test, you encounter a probability question and you're not really sure how to start it or where to go through the BINS checklist and see if it might be a binomial or geometric. So keeping that in mind, let's look at part A. What's the probability Sam's first upgrade will occur after the third flight? So I'm just going to show you how we can go through the BINS with this. So the B is binary. There's two outcomes. So here my two outcomes would be either he gets upgraded or he doesn't get upgraded. So that works. I, independent trials. Well, it tells you right here the outcome is independent from flight to flight. Okay, so we know that that's met. And then as far as the N, do I have a fixed number of trials or am I counting trials till a success? If we read the problem, we're counting the trials. Okay, in other words, each trial would be a flight. We're counting the number of flights it takes until he gets his first upgrade. So that's why this is a geometric and not a binomial. Okay, for it to be and we'll see one in a minute where it's a binomial so you can kind of compare it. And then S, is the success probably the same for each trial? If you go back and look at the question, they tell us that 0.1, so we're going to assume that's the probability of success. So that's how we know it's a geometric. And then once we know it's a geometric, I'll show you how to set it up now. Okay. So for part A, we talked about how we know it's a geometric, and we want to find the probability it occurs after the third flight. So that would be the probability X is greater than 3. You may remember how the calculator is set up. It will not do a greater than problem for a geometric or a binomial for you. So in this instance, I'm going to do 1 minus the complement. So I'm going to do 1 minus the probability that X is less than or equal to 3. Before we talk about the formula, I'll kind of skip that part for a second. Just remember on the calculator then, you can do 1 minus geomet CDF. If you forget where that is, I'll show you right now. And my calculator is low on batteries. So you hit second vars. Okay, so second and the vars key. And then you're going to arrow down. And then I'll also be referring to binom too. So there's where you find the binom and the geomet. Okay, it's under second vars. And in this case, I can do 1 minus geomet CDF. What do you type into geomet? The probability of success, which is 0.1. And then in this case, we're counting the trials till a success. So it's the third trial. Okay, and the CDF starts at 1 and counts up. So it would be anything from 3 and below. And then as far as the formula, remember, you do not need to memorize formulas if you're taking the AP test. You can use that AP formula sheet that I gave you, or you can make your own formula sheet that you can reference. But just as a refresher, and this is also on your formula sheet, this is the geometric probability formula. If you want to find the probability that X equals N, which is saying that the probability you get your first success on the nth trial, it's equal to 1 minus P to the N minus 1 times P. remember, this is really just the multiplication rule. So if the formula makes it seem more confusing to you, then feel free to just kind of ignore it and think about it. So as far as writing out the formula for this, which remember, if it's a free response, you're going to need to write out the formula, and we know we're only going to have free response questions this year. So less than or equal to 3. So that means I could get it on the first trial. So this is the probability of getting a success on the first trial. It's just that 0.1. Or I might not get it till the second trial. So that means the first trial is a failure and the second trial is a success. Or I might not get it till the third trial. So that means the first 2 trials are failures. So that's why it's 0.9 squared, and the last one is a success. Okay, and those 3 added together would make up this part. So that's how you would write out the formula. Okay, let's move on to part B. What does part B says? Part B says, what is the probability that Sam will be upgraded exactly 2 times in his next 20 flights? Okay, so if we go back to the bins, the difference between this one and A is the N here. Okay, they tell you a fixed number of flights, which is like the trials. So there's 20 trials or 20 flights, and we're counting the number of successes, the number of upgrades. So that's what makes this one a binomial as opposed to geometric. The other 3 things are the same. So we know it's a binomial, and then I'm just going to put up the binomial formula. Again, you should have this too, but just as a refresher, the binomial formula is if you want to find the probability that x equals k, where k is the number of successes. It's n, where n is your number of trials. N choose k, p to the k, 1 minus p to the n minus k. When we did this, just a couple of reminders. Remember, p and 1 minus p, these always add up to 1. And then your exponents, these 2 added together, should always equal your number of trials. Okay, so how would we set that up for part B? 2 times in his next 20 flights. Oops. So this guy would be, it would be the probability that x equals 2. Okay. And so it's going to be 20 choose 2 because I have 20 flights. And then this is my probability of success. It's 0.1 to the second because I want 2 successes. And then 0.9 is my probability of failure. I'm going to have 18 failures. So this is how you would write it out. And then on the calculator, you're going to go to the same spot I just showed you, which is second vars. And this time you would go to binom PDF. Why are we using PDF as opposed to CDF here? Because it's equal to a given probability. If it's an inequality, we use CDF. If it's equal to a given value, we use PDF. And then you can get that right off the calculator. What goes into binom PDF? It's n, which is n is the number of trials. P is the probability of success. And K is the number of successes. Okay, so just a reminder, that's what you type in. Okay, let's move on to part C. Part C says Sam will take 104 flights next year. Would you be surprised if Sam receives more than 20 upgrades to first class during the year? Justify your answer. So we probably need to first figure out how likely it is that he would get more than 20 upgrades, and then use that probability to kind of answer the question about if we would be surprised. So C, is it binomial or geometric? Well, if you said binomial, you're right. And the reason is because there is a fixed number of trials. He's taking 104 flights, and we want to find the probability he gets more than 20 upgrades. Okay, so that's why this one's a binomial. So just kind of showing you how you would set this guy up. We want to find the probability that x is greater than 20. He gets more than 20 upgrades. Remember, the way the calculator is, it will not do greater than. So I'm going to do 1 minus the probability that x is less than or equal to 20. So on my calculator, it would be 1 minus binom CDF. I'm using CDF here because it's an inequality. 104, because that's the number of trials. 0.1 is the probability of success. And I want to find the probability of getting 20 or fewer successes. Okay, then I'm going to do 1 minus that. So that's how you would do it on the calculator. As far as writing out the formula, just remember, if it's an inequality like this, you don't need to list out all the values. So I don't need to list out everything for 20 or below. So I'm just going to write it out for 0 and then for 20 and put a plus dot. Didn't do a very good job of writing that there, but it should be a plus dot 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 in between. So I'm going to start with 0 successes, which is this part here, all the way up to 20 successes. And I would do 1 minus all of that stuff added together. So our probability is 0.0014. So if we like turning that into a percentage to kind of give us some perspective, we'd move the decimal point over 2 spots. So it's like 0.1%. So it's very unlikely that would happen. So to answer the question they're asking about, would you be surprised? I would say the correct answer for C should be yes. Yes, I would be surprised because there was such a small chance of it happening, or the probability of it happening is very small. So it's not impossible, right? Maybe Sam gets lucky and he happens to get those upgrades, but the odds are not in his favor. So, okay, guys. Well, thanks for watching, and I will talk to you again soon.